Hi, I'm Tim Cole, and I'll be talking about using mark recapture derived mortality estimates for right whales to assess the effectiveness of management actions. In this talk, we're proposing the use of mark recapture derived mortality estimates to assess the effectiveness of management actions for reducing right whale mortality. This talk is not about an assessment of past management actions, although we use the response by the Canadian government to right whale mortality events in the Gulf of St. Lawrence to show their correspondence to the mark recapture model's results. The results suggest that the model can assess the effectiveness of management actions, at least for responses to large mortality events. A second important point is that there remains a baseline level of mortality that exceeds what is sustainable for the population to grow, and more range-wide conservation is needed. The image here is of a wolverine who had already been entangled 3 times and struck by a vessel 1 time in his short life before being fatally struck again in 2019. These estimates of annual right whale mortality are from Linden using a mark recapture model initially developed by Pace et al. The graph's y-axis indicates the estimated number of right whale deaths, and the x-axis shows the years from 1990 to 2021. The model uses annual photographic captures of right whales and estimates deaths based on absences of individuals over time. Because of the fairly comprehensive annual photo ID effort by survey teams, a living right whale is very unlikely to go unphotographed for more than a couple years. There are 4 features of this mortality model's results that we want to highlight. The red line shows a dramatic increase in right whale deaths from 2014 to 2017. The blue line highlights extreme fluctuation in right whale deaths from 2017 to 2020. The heavy dashed line is for reference to show a baseline level of mortality from 1990 to 2010, and that has continued the last few years of the time series. And lastly, the small dashed line in gray near the very bottom of the graph is the current PBR, which is an estimate of the level of mortality the population can sustain and still grow. 2010 is commonly referenced as the year things changed for right whales, but evidence suggests 2014 is when the mortality started climbing steeply. And in 2015, the median mortality estimate was 3 times higher than that for the majority of years prior to 2010. So what happened in 2015? Potentially lots of things, but what stands out of what we know is that 2015 corresponds to when there was an increase in detection of right whales in the Gulf of St. Lawrence. The blue line traces extreme fluctuations in estimated right whale deaths from 2017 to 2020. So what was happening? Again, potentially lots of things, but what we know is that the Canadian government implemented management actions in response to the right whale mortality crisis in the Gulf in 2017, and that these actions differed between years. These different management actions constitute treatments to the causes of mortality. In the graph, you can see the mortality crisis in 2017, a partially successful treatment for the causes of mortality in 2018, a change back to a high level of mortality in 2019, and then another apparently more successful treatment in 2020 that persisted into 2021. What corresponds best to this fluctuation in mortality are changes in closures to the snow crab fishery in the Gulf from 2017 to 2020, examples of which are shown in the panels to the right. There was no closure until July 14th in 2017. For the other years, we're showing the closures in place by June 15 because discovery curves from photo identification efforts suggest that the majority of individuals visiting the Gulf arrived by then. This is not a direct assessment of these closures, but based on the mortality estimates, it seems likely the closures in 2018 and 2020 helped treat the causes of mortality, and not just entanglements. Of the 21 total mortalities documented in the Gulf in 2017 and 2019, the cause of death was determined for 10 of them, of which 8 were from vessel strike and only 2 from entanglement. But there were also 9 entanglements documented in the Gulf during these 4 years, 2 of which were likely fatal and 3 of which would have likely been fatal without intervention. The last feature of this model's results is this baseline annual mortality that has persisted for the better part of 30 years, despite numerous management actions. It is unclear where most of this mortality is happening. The necropsy data indicate that no adult right whales have died of natural causes in the last several decades, and roughly 50% die from entanglement and 50% from vessel strike. Some of the baseline mortality occurred and likely continues to occur in Canadian waters, but we know vessel strike and entanglement mortalities and serious injuries happen in the US too. Further efforts are still needed range-wide to reduce mortality and support growth of the right whale population. The correspondence of the model's mortality estimates to the events in the Gulf suggests the model could be used to evaluate the effectiveness of management actions to further reduce this baseline mortality. Thank you.